In a long line of people arranged left to right, the 1013 person from the left is also the 1010 person from the right. How many people are in the line? We have a whole bunch of people, dot, 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 and then eventually you get to the 1013th person. And then, let's see here. We also, so that's from the left. Okay, so we're coming from the left. Wait, hold on. I think I mixed this up. No, I'm right. Just second guessing myself. And then from the other direction, you are coming from the right. And eventually you get to... Oh, also, okay, so the same person is the 110th person. Okay, I got it. So let's see. They want to know how many total. All right, well, that shouldn't be a problem. From the here to here, that's 1013. Correct? And then from here to here, that's 1010. So the total would be 1013 plus 1010, but because we counted this guy twice, we have to subtract it once. So this all comes out to 2022. So that would be answer choice B. What is 10 factorial minus 7 factorial times 6 factorial? Let's factor out a 7 factorial, and when we do, we get 10 times 9 times 8, and then that would be minus 6 factorial. And I think at this point, well, I'll just do it manually. This is 720, and that's 720. Oh, okay, well, I guess that's 0 then. So it all boils down to 0. So A is, let's see, what's the answer? B. For how many integer values of x is the absolute value of 2x less than 7 pi? So the absolute value of 2x is less than or equal to 7 pi. So 7 pi is what, approximately 21.98. Okay, so they're concentrating on integers, right? So if I drop the absolute value, the inequality becomes 2x is greater than minus 21.98 and less than positive 21.98. So I have to divide through by 2, and I get like minus 10.99 approximately. 10.99. And then you're just looking for integers in that range. So it would be minus 10, minus 9, minus 8, so on, all the way till 0. And then on the other side, you'd have 1, 2, all the way till 8, 9, and 10. And when you add up all these guys, there's 21 of those integers. And therefore, the answer is this E. Balls numbered 1, 2, 3, dot, dot, dot are deposited in 5 bins labeled A through E using the following procedure. Ball 1 is deposited in bin A, balls 2 and 3 in bin B, next 3 balls in bin C, next 4 in bin D, and so on, cycling back to bin A after balls are deposited in bin E. What bin is ball 2024? So let's understand this question. First, let's put the 5 bins, and they're labeled A, B, C, D, E. And let's go through the process here. So first, we are going to put ball number 1 there, 2 and 3 here, 4, 5, and 6 here, 7, 8, 9, and 10 in this bin, and then 11, 12, 13, 14, 15 in that bin, like that, and then so on. And then we go back, there would be another 6 in here, so all the way, balls 16 through 21, 7 in here, so balls 22 until 28, and so on. You guys get the point. So what are they asking for? They want to know which of these 5 bins is the 2024 ball. Okay. All right, well, let's see here. It looks to me that how many numbers are in each box? Well, cumulatively, right? So let me think about this. So I guess you're just adding 1 plus 2 plus 3 plus 4 and then so on, right? 5 up to some number. And that number eventually get up to 2024 in terms of the total numbers there. Yeah. Okay, so you guys remember that formula, n times n plus 1 divided by 2. And in this case, it's 2024. Now, I'm not going to do a quadratic. I'm just going to do n times n plus 1 is equal to 4048. And I'm going to approximate it. So this is sort of like n squared. It just makes it quicker. And then if I take the square root, I'll get approximately 63. So that's not the actual value of n, but it's close to 63. So let's work with that. So if n is 63, that means that this expression would be 63 times 64 divided by 2, which is 2016. So that is sufficiently close to that guy. So that's pretty good. So that makes me think the following, that the number 1 goes into A, the next 2 numbers go into B, the next 3 numbers go into here, the next 4 go into D, the next 5 go into here. But if we were to use n equals 63, that means the next 63 numbers would go into a certain box, right? And that can be easily figured out which box, because every fifth box is E. So if a number is divisible by 5, it would be E. Now 60 is not divisible by 5. The 60th box is E. But then when you continue this process, the 61st box would be A, the 62nd box would be B, and the 63rd box would be C. Okay, that makes sense. But then we still haven't got up to 2024. We only got up to 2016. So that means to get to 2024, we would have to add 64 numbers in D, and one of those numbers would be the 2024. There'd be 64 numbers, and one of them is 2024. So that's kind of like how you would extrapolate this question. So the answer is D. In the following expression, Melanie changed some of the plus signs to minus signs. When the new expression was evaluated, it was negative. What is the least number of plus signs that Melanie could have changed to minus signs? Okay. When you do this whole thing, according to that formula, it would be 99 times 100 over 2. And that is... wait, hold on. Oh, no. This is not consecutive. I got to read the question carefully. It's skipping over. These are odd. Oh, okay. So if it's odd, then you can't use that formula. It's a good thing I looked at it more carefully. I thought it was consecutive numbers. Okay, well, it shouldn't be too hard. If you pair them, 1 plus 99, 3 plus 97, and so on, you will get that every pair is 100. And then how many numbers were there? 1 through 99, every odd number, so there's 50 of them. So there's 25 pairs. Yeah, so let me just put that here. 25 pairs. And each pair is valued at 100, so it'd be 25 times 100 is the total. So 2,500 is the sum of those numbers. Okay, so that's the first part of that question. Now, the second part is we have to somehow make it a negative. We have to, by changing a bunch of signs there. Interesting. Okay, so that means I'm probably gonna, and the key word there is least. So I want to do it in a way that I put the least number of plus signs that Melanie could have changed to minus. So basically what they're saying is the least number of negatives that I need to put. So that means I'm probably going to concentrate on the bigger numbers. I'm going to make those negatives. That way I don't have to put that many. So the smaller numbers will remain positive, and then somewhere along the line there's going to be a whole bunch of negatives. 97 minus 99. So I have to figure out how many of these guys are negative. Okay, I got it. And then this whole expression is negative, so less than 0. Okay, let's work with that. So then how do I do this now? Actually, I'm just reminded of an expression that the sum of the first odd numbers is n squared. Like, for example, let me give an example. All the way up to n is n squared. Let me see if that holds up. I don't think it's n squared. Let me think about what it actually is. I think I wrote this wrong. It would be the sum until 2n minus 1 is n squared. I think that's correct. So in our formula up there, this guy, this original one, the 2n minus 1 would be 99, and therefore 2n would be 100, n would be 50, and therefore the n squared would be 2500. Okay, that checks out, and you can verify that it checks out with any other kind of value. Okay, that's very helpful that actually I remembered that, because I knew there had to be some formula. I actually remembered the sum of the consecutive numbers formula, but this is the consecutive odd numbers. Okay, so applying that formula to this expression, it would basically be n. Well, let's use a different variable here, since I don't want to confuse this n with this m, this letter. So I'll use m. It would be m squared, and then for these guys, and then it would be, you're subtracting a whole bunch of numbers. So you're subtracting, in this case, it's this guy, so it would be 50 squared minus the m squared, because again, you have to subtract this, and that's less than 0. Pretty sure that's correct. So then when you take it out of the brackets, it'll be 2m squared, and if you put this on the other side, it'll be 50 squared, and if you divide through, you'll get m squared is less than 2500 over 2. So that's going to be m is less than 1250 under the square root sign. So m would be less than approximately 35 point something, 0.3. So if that's the case, then that means my 2m is less than 70.6 or 7, something like that. And then 2m plus 1 would be less than 71.7. I got it. So that basically means that the first one would be less than 71, so less than 71.7, so 71. And then dot, dot, dot. So that is how you get this number. And that's very important. And then you have to just count how many numbers there are from there to there. 71 until 99, the odd numbers. And when you do count them, you get 15. So 15 is the answer. So that would be B. A rectangle has integer side lengths and an area of 2024. What is the least possible perimeter of the rectangle? So we've got a rectangle here, and let's just label it A and B, and the area is 2024. So that basically means that A times B is 2024. Got it? Okay, so I'm going to factor this into prime factors, 2 to the power of 3, 11, and 23. For it to have the least possible perimeter, that would basically mean that A and B would have to be close together. A, B should be close together. So, for example, I could choose A is equal to 1 and B is equal to 2024, right? But if I did, the perimeter would be 2A plus 2 times A plus B, which in this case is 2 times 2025, which is 4050. Now that's a very large number. I'm pretty confident that I can get a much smaller number for the perimeter, because that's what they want. They want the least. And the least possible perimeter is obtained when we get A and B close together. And this is the extreme case scenario where they're as far apart as possible. Okay, so you basically fiddle around with this. That's when you break it up into prime factors, it allows you to kind of fiddle around with things a little bit easier, to get numbers, possible options. So let's see here. If I make, You got 23, so if I take the 23 and multiply by 1, 2, that's 46, and that leaves 2 times 2 times 11, which is 44. That's pretty close, actually. I don't think you're going to get anything closer than that. Yeah. Okay, so then therefore this one would give me a perimeter of 2 times a plus b, which would be 90, and that's 180. And as you can see, 180 is significantly less than 4050. So 180 is the answer, and that would be B. What is the remainder when 7 to the power of 2024 plus 7 to the power of 2025 plus 7 to the power of 2026 is divided by 19? All right. Well, these questions, well, actually, I was going to actually look for a pattern, which is what I always do with these kinds of questions, where you just look at 7 to the power of 1, 7 to the power of 2, and you keep doing this, and then eventually you see that the units digit kind of repeats itself. So in this case, it's 7, 9, 3, 1, because I remember this, and then it becomes 7, 9, 3, 1, and so on. But I don't think that is even necessary, because this question, you can just factor out a 7 to the power of 2024, and when you do, you get 1 plus 7 squared. And then this actually makes things much easier for me, because now this is easy to calculate. That's going to be, well, what is that? 49 plus 8, so 57. And then they're saying when you divide this by 19, what is the remainder? Well, 57 is divisible by 19. It's 3. So you get 7024 times 3. So there is no remainder. Remainder is 0. So that's it. So that's pretty much all there is to that one. Let n be the product of all the positive integer divisors of 42. What are the units? What is the units digit of n? Okay, so 42, we have to first figure out the divisors, and of course we got to break it up into its prime factors. And then I'll just manually list all the prime factors. 1, 2, 3, 7, 6, 14, 21, and 42, right? There should be 8. 1, 2, 3, 4, 5, 6, 7. Yep, 8. Okay, so then what now? Oh, we got to multiply them all. Oh. Okay. It's going to be a very big number here. Boy, oh boy, oh boy. So I'm trying to think of a quick way of doing this. Well, the 1 is not going to contribute anything. So we have a 2, we have a 3, we have a 7, we have a 6, which is 2 times 3. We have a 2 times 7, we have a 3 times 7, and then we have a 2 times 3 times 7. This basically will be, let's see here, how many 2's do we have? 2 to the power of 4, 3, 1, 2, 3, 3 to the power of 4, and 1, 2, 3, oh, 5, and 7 to the power of 4. So this is basically 2 times 3 times 7 all to the power of 4. And that's 42 to the power of 4. Okay. And 42 squared to the power of 2. 42 squared that's pretty easy. That's 1764. So 1764 squared is the product of all the positive integer divisors. Now you can multiply this out, or you can just look at the units digit. What's 4 times 4? 4 times 4 is 16, right? So now I don't know if the last two digits will be 16, but I am pretty confident that whatever this is, that, let's see, it probably is a 7-digit number. I'm pretty confident that the last digit is 6. Now, when you actually do multiply it all out, it's 3111696. But we don't care about the 9. We just care about the units digit, and it's 6, as I had originally said, and therefore the answer would be D. Real numbers A, B, and C have an arithmetic mean 0. The arithmetic mean of A squared, B squared, and C squared is 10. What is the arithmetic mean of A, B, AC, and BC? So they have told me that A plus B plus C, that mean is 0. And then they're saying that the arithmetic mean of a squared plus b squared plus c squared, that mean is 10. And then they're saying, what is the arithmetic mean? So basically what the question is saying is find AB plus AC plus BC over 3. Okay, shouldn't be a problem. All right, so from the first equation, I get that A plus B plus C is 0 when you just multiply through by 3. And from this equation, you get that A squared plus B squared plus C squared is 30 when you multiply through by 3 there. And I'm not sure if that helps in any way, but I guess we'll go from there. Okay, so then in order to get these guys, I'm pretty sure that you'd have to take A plus B plus C and square it. And when you do, you get A squared plus AB plus AC plus AB plus B squared plus BC. Let me see if I did that right. Yeah, plus AC plus BC plus C squared, right? And then when you group these, you get A squared plus B squared plus C squared. And then you have plus 2 times AB plus BC plus AC. And this is all A plus B plus C all squared. Okay, and I think we can substitute things in now. This guy is 0, so that's just 0 squared. This guy here is 30. And then this is what we are trying to find. Almost. Not quite. We have to divide through by 3 at the end, but that shouldn't be a problem. Okay, so now when we solve this, it looks to be like minus 30 over 2 is your AB plus BC plus AC. And then they want you to divide it by 3 because they want the mean. So no problem. If we divide through by 3, this over 3, this over 3, it basically becomes minus 30 over 2. Invert and multiply. So that is minus, let's see here, minus 30 divided by 6, that's negative 5. So negative 5 is the answer, and that would be A. Quadrilateral ABCD is a parallelogram, and E is the midpoint of side AD, and F is the intersection of the lines EB and AC. What is the ratio of the area of the quadrilateral CDEF to area of CFB? All right, let's draw it first. Let's get some sort of an understanding of what it is that they're asking. And let's see here. So we got a quadrilateral. It doesn't have to be too fancy here. And let's label it. So we got A, B, C, and D. And then what? They gave me a couple more letters, right? E is the midpoint. So E is approximately here. So that's E right there. And then what else did they give me? F is the intersection. Oh, there's some lines here I've got to draw. And let me see. I've got to draw these lines. Where the BE, that's the first line. And what's the other one? EB and AC. Oh, okay, so the absolute diagonal there. And then that intersection is being called F. Okay, I got it. Okay. Oh boy, so then what do we do here? What are we trying to do? Ratio of CDEF to triangle CFB. So CDEF, okay, that whatever that is, that shape, and then CFB is a triangle. All right, so I think we're gonna have to use similar triangles here, because I immediately see that triangle AFE. That's similar to triangle. Which triangle? BCF maybe. BCF. Yeah, BCF. Yeah. Okay. And then I think we're going to need some altitudes here. So let me draw on a line that represents the altitudes, but I'm going to use a different color so that you guys don't get confused. So the altitudes are sort of a straight line top to bottom. A straight line top to bottom like this. Here, that doesn't look straight, but well. Okay, so that's about as straight as I can make it. So here we go. So the altitude for that top guy I'll call H2. And I know it's hard to see, but the altitude for this bottom guy I call H1. All right, so here we go. So in triangle ABE, right? That half, I guess. The area is going to be 1/2 base. 1/2 base times height. Okay, not a problem. But I'm going to have to actually label some of these guys because I have to. I don't want to use AE and all that stuff. It's going to be too confusing. So let me just use that as BC, call it Y. And then from A to E would be Y over 2, right? Because AE, well, E is the midpoint. And then the total height top to bottom, I'll just call H. Well, I'll just put H over here. So 1/2 base times height. The base is Y over 2 and the height is H. So this is basically just YH over 4. And then the BCDE, BCDE, that, I guess, section of the quadrilateral would be the full area, which would be Y times H, the full quadrilateral, which would be ABCD, minus this YH over 4. So that would be 3/4 YH. So hopefully that makes sense. And now I think we can utilize what I had seen originally in this question, that the triangle AFE is similar to triangle BCF. BCF, I call it BCF. BCF is the same as CFB, right? Yeah. I just switched the letters for some reason, but it doesn't matter. It's the same triangle. Same 3 endpoints. Okay, so using similar triangles, that would mean that CB over AE would be Y over 2, and that would be 2 over 1. Okay, and then also CB over AE is H2 over H1, and that's also 2 over 1. So that basically means that H2 is equal to 2H1, which helps a lot. And we also know that H1 plus H2 is equal to the big H. So that basically means when we sub this in, that H1 is equal to H over 3, and H2 is equal to 2 over 3 times H. All right, that's very good progress actually so far, just with similar triangles, which is what I had originally thought of as soon as I looked at the diagram. Okay, now I think we're pretty much close to being done. The area of CFB shouldn't be that difficult now. It's 1/2 base times height, so the base is Y and the height is H2. So Y times H2 is over here, 2 over 3H. So that becomes YH over 3. And then this guy, the top guy, so we're done with this. We've got that. The CDEF, that is actually BCDE minus BCF. Yeah, or CFB, whatever that you want to call it. CFB. So BCDF, I think we got that over here. That's 3 over 4 YH. And then CFB, do we have C? Oh, CFB is right here. So that's YH over 3. And then when you do that, get a common denominator. Let's see, we'll get 9 minus 4, so that's 5 over 12 YH. Okay, so we have that as well. So I might as well just do it over here. We've got both. CDF is 5 over 12 YH. And CFB, where is it? It's here. That is YH over 3. And then the YH's cancel. So it'd be 5 over 12. Invert and multiply 3 over 1. So it'd be 15 over 12. And in lowest terms, what's that? Divide through by, it'd be 5 over 4, I believe. Okay, so 5 over 4 is the answer, and that looks to me like A.